This is a P7 video looking at Fleming's left-hand rule. Starting off, let's go back to some basics, okay? So magnetic field lines. If we look at this magnet, we can see that the field lines flow through the magnet from south to north and then come out of the north, in through the south. Okay, that's our first bit of information that's really important to know. Then let's look at two attracting magnets. Okay, so here we've got a north and a south attracting each other, two separate magnets, and we can see here that once again, just like in the previous picture, the magnetic field lines come out of the north and then into the south of the other magnet. So here, okay, in through the south, out of the north, and then we've come out of the north going into the south. So that helps us with field lines. Okay, so field lines, you can see the F on my finger there for my first finger, go from north to south. That's one really important piece of information. For working out the current, okay, we can see down here, okay, the positive terminal and the negative terminal. Now current flows from positive to negative, so that's going to give us the current. Okay, so the current is coming along this positive, from this positive terminal all the way along this wire, which I've held just gently in these clamp stands to hold it in the middle of the magnet. And so the current is coming this way. Okay, so I now know two things. I know that the field lines are going this way, from north into south. I just got that from my picture. And I know that the current is coming this way from the positive to the negative terminal. Okay, I'm just going to readjust so we can see everything. Okay, so we can see my hand. So I know the field lines are going this way, and I know the current is going this way. Hopefully you can see this okay. Let's just adjust it slightly again. Okay, so current is going this way, field line this way. That means the motion, which is the M on my thumb, is going up. So when I put this power supply on, I should see the motion of that wire that is just gently held in this clamp stand going up. Let's have a look if my prediction is correct. There it is, it went up. Okay, let's put it back in position. Let's show it one more time. So there it is, just balanced in the middle of the magnet there. I've got my current going towards me. I've got my field line going from left to right, from north to south. And the motion, using the left-hand rule, predicts that the motion should go up. Let's have a look. And there you can see the wire shot up. Okay, let's do it one more time, just so that we can see it. Move that down slightly. Okay, let's turn on. And the motion was up. Okay, I've turned the power off. I'm going to do the opposite situation. I'm going to turn the magnet round. I've now got a field line that is going in the opposite direction. Okay, so this time my current is still coming down towards me because I haven't changed the terminals. Okay, my field line this time is going from this way, north, to south. Okay, so that's where I've got to take my hand and turn it. Okay, I'm just going to adjust the camera so that you can see. I'm going to take my hand and I'm going to turn it. Okay, so my field line, this one, okay, going from north to south. My current, this one, still going from the back of the table forward, and that takes the motion down. Motion was my thumb. Okay, so where I was like this, with my field going this way, my field is now going completely the opposite way. I'm turning it that way. Field, I hope you can see this, let's turn here. Field this way, current this way, motion down. Let's have a look if my prediction is correct. And there it is. The wire moved down. Okay, the motion of the wire moved down. Let's do one more time. And there it goes. Okay. I'm going to hold my hand in that position just one more time to hopefully make sure you can see it properly. Okay, so my field line, north to south. My current going from the back, positive terminal is this side, negative terminal is this side. So there's my current, motion down. And there it is. Okay, let's have a look at that using the pictures. Okay, bear with me. Okay, so this is the first scenario I had. So I had the field lines going from north to south, field lines. I had current coming down the page, okay, from the positive terminal here, round, coming down the page to negative, and the force is up. Okay, so there's how I've used the left-hand rule. Let's have a look at the second scenario. Second scenario, in this picture I couldn't get a picture that looked exactly like the other one with south on the other side, so bear with. We've changed the current. The current is now going this way. Okay, so there's the current, but that takes my force field the wrong way round. So the only way to get my force field corrected is if I turn it. Now my current's wrong. So I take upside down my current, this finger, going from the front, the positive terminal, to the back, the negative terminal. My force field going from north to south, motion down. Hopefully that helps. Now let's look at it in terms of a motor. Okay, so now the motor is going to turn. Okay, let's take this back a bit. The motor is going to turn. So because the wire goes around the motor, we've got the current going this way and we've got the current going this way. So we just focus on one part of it at a time. Let's focus on this part first. So the current is going away from me. That's lined up the current, hasn't lined up the force field. The force is going from north to south. So this is where I need to turn upside down. Here's my current going this way, backwards. Here's my force field going from north to south. So my motion down. And you can see that here, the force is going down, but this is rotating clockwise. Let's have a look at this side then. Okay, so I've got my current coming down towards me. I've got my force field going from north to south, and the motion is pointing up, and we can see here the force is going up. Okay, so that creates that clockwise motion of the motor. Hope you found that useful. Thank you.